Hi, I'm Kevin O'Connor, and welcome back to Ask This Old House, where we'll go anywhere to answer your home improvement questions. Today,
I'm going to show you how to give your old door some real character by replacing your basic doorknob with some antique hardware. All right, Kevin, that's how you do a Dutchman.
absolutely seamless. And when that new old hardware goes on, this door is going to look great.
And I'll show you a geothermal heat pump, how you can use the ground to heat and cool your house.
Okay, Tommy, here's today's project. This is an original 6-panel door from the 1930s, and at some point, somebody took out the original hardware and replaced it with this hardware. It's a cheap brass knob, it's got a round back plate, and you can see here on the edge that they pulled out an original full mortise lock set. You can see the outline right there, and they filled it in with putty, and they replaced it with this smaller tube lock set right there.
Right, it is a cheap doorknob.
So maybe we can switch this out and put something that looks good on this door.
Well, here's a door about the same period, and it's got original hardware on it. So I would imagine that maybe the hardware on that door looks similar to this. It's got a smaller plate, and it's got a full mortise set right here. If you want to get this look, you have a couple of different options. You can go to a store and buy reproduction hardware.
Which is actually new hardware just made to look old.
Exactly.
Right.
Or you can go to an antique store that has old hardware and see if you can find some.
Well, I know of an antique store nearby, so why don't I go give it a look?
Okay, sounds good. I'll see you when you get back.
This is an architectural salvage shop that we have been to before. We recently purchased a mantle for around a fireplace for a job, and we knew that they had a great selection of doorknobs. And not just any doorknobs. These are actually antiques. They're matching pairs, and they've been reconditioned so that you can buy them in working order. Work that has been done by Bill Raymer. Bill, look at that selection that you've got here, huh?
Kevin, we've got a great selection. How you doing?
I'm doing well. That's
Great.
terrific. You've also got a little bit of a history lesson for us, too, right?
I can tell you a little bit about doorknobs. We could start at the beginning if you'd like to know.
Yeah, what is the beginning?
Well, the beginning, the early handles of doors would be this thumb latch, which is on a very thin door, and it's a very simple mechanism, and it just opens the door like so.
Doesn't get much simpler than that, does it?
Very simple. Didn't really have any locking mechanism.
What's the
either.
date of something like this?
This would be, late 1700s up to 1800 or so.
Okay.
Okay. Then what they did is they refined the process a little bit. They came up with what's called a rim lock. This is a surface mount lock that would mount to the face of the door, and then this catch, a keeper, would mount to the jamb, and they drill a small hole in here and put a doorknob through here, and that's what open and close the door.
But you would see the hardware because, as you said, it was on the face of the door.
Yeah, surface mounted. You would see that. So then what they did is they refined that a little bit. They went to what's called a mortise lock, which they mortised into the side of the door, like so.
Similar mechanism. Now it's just hidden inside the door.
It's just a hidden mechanism. Again, your doorknob and your spindle go right through here.
Right.
And then they progressed into what's called a tubular latch. And the reason they did this was it's just much simpler to install. It performs the same function as the mortise set, but it's much easier to install. It's just easier and simpler.
No mortise along the side. A single circular hole in the face of the door, and it works the mechanism as well as the handle.
Right. This still has to be mortised into the door, but you don't have to drill such a large hole in the door.
Well, this is the one here that interests me, the mortise lock. We've got to find an appropriate doorknob for something like this, a mortise lock.
Okay, well, I can tell you kind of, where we're going.
Please.
So there's different types of doorknobs. In the early to middle 1800s, they had porcelain knobs. They were generally made of in 3 different colors, white, black, and brown. The brown is sometimes known as Bennington because it was created by a company called Bennington.
Beautiful swirls in that one right there.
Yeah, that's really refined the process. Then there was some wooden knobs that were early, middle 1800s, and they were very crude in some cases. And in some cases, they began to refine them and add more detail.
But these are both from the same period. And then moving on from there, what did we go to?
Well, middle 1800s up to the turn of the century, we had brass and bronze knobs.
Beautiful.
Okay, there were 2 different types of manufactured knobs. They were usually very ornate, and there were 2 styles. One was a stamped brass, which was thin and actually stamped out on machinery.
So this is stamped here?
This is stamped. Yep, this is the thinner one, and this is the cast brass, which is heavier and very decorative, as you can see.
They are beautiful, and that one's actually quite beefy.
Yeah, this would cost more money, where this would be more like the builder's hardware of the day.
Okay.
Then from there, progressed a little further, getting a little fancier, into glass and crystal knobs.
Great, look at that. Cut, made by hand, I assume?
Cast brass rosettes, and some had a wide shank base like this.
Yeah.
Many of the styles were octagon. That was, the style of the period. And then they had what's called a mercury knob, which was a fancy, almost mirror image glass knob. It actually didn't contain any mercury, but it was called that. It was a process invented in Germany, and it made its way over here.
That's good to know that there's no real mercury in
That's
that.
good. We don't want any of that. That's
and
for
then
sure.
it continues on with glass knobs. There's big selections we got
Glass knobs,
here.
all different types. After the, from this would be 1910 up to 1920 or so. Then we come to the 30s, we're still using glass, and the back plates, which would be, from the 30s, either a back plate or some styles would have a rosette, which is the round back plate.
Well, this piques my interest because I'm looking for something around the 1930s, and I can tell from that wall behind you, I am going to find a doorknob that I need.
Well, we've got a great selection, so we can, you can spend some time here and pick something out. There's
I'd love
just
to.
a couple things you want to remember about doorknobs, okay? One is you have to get one that fits the thickness of your door.
And the thicknesses of doors could be all different thicknesses,
Yeah,
right?
the early ones were 1 inch. Then the most common one is 1 3/8, and then they went to 1 3/4, depending on the size of the house. Okay.
So what am I looking for?
Well, there's 3 types of spindles. One is a fixed pin spindle.
Yeah.
Okay, which for your period really doesn't apply. And then the 3-hole on each end, which would give you this adjustment.
So these actually go up into one of those three positions
This can go into either one of these 3 holes, like so.
on either side.
On either side, so you can fine tune the adjustment for the thickness of the door.
Right.
And then the 1930s ones that you were interested in, actually screwed on. And this refined the adjustment even more because you could just make it fit perfectly.
And then you just set it down. There's a little set screw there to tighten it up.
There's a set screw here, you tighten it up, and you're all set to go.
That's actually really good to know. All right.
Well, the last thing you need to know is that if you have this new bore style, okay, that's going to create a bit of a problem because you're going to have a 2 1/8 inch hole bored in the door.
Right.
Much of the antique hardware will not fit that, but when you're looking for a back plate, okay, so let's say you're looking for a back plate for the 1930s,
Yep.
you want to make sure it's big enough to cover that hole.
All right.
That's the key.
And if we don't, we've got ourselves some work to do.
Then you're going to have to do some work.
All right. Well, I'm going to dig into your collection here. Thank you, Bill.
Okay, go for it.
Tommy, I found some great antiques, any one of which is going to be a great improvement over this old brass knob here.
Yeah, that's for sure.
I mean, look at these. These things are original, beautiful. We've got an Art Deco backplate right here. We've got a rectangular one right here. And we've even got some of these rosettes, original metal rosettes, brass. And look at the knobs.
Beautiful.
3 glass knobs,
Beautiful
1
glass
metal
knobs.
one.
Yeah, they're absolutely beautiful. Well, I have some reproduction hardware right here. This is absolutely new hardware, made to look old. Porcelain knob, glass knob. Look at how nice that is.
And the rosette here or the backplate. Really nice stuff, too.
Now, the good thing about this is the manufacturers, when they make it, they allow for a hole that may exist in your door from the old doorknob.
This is a traditional borehole here.
Right, 2 1/8.
2 1/8 inch, right.
And so now the plate would cover that hole perfectly.
So they're actually thinking about that when they're making this stuff for you. They want it to look old, but
They
functional.
modified it slightly.
Right.
See? So now the problem is when I hold this plate over that hole, right here you have the screw holes. The screw holes has no structure.
Covers the hole, but nowhere to screw into.
So they make right here is what is called a bore insert. You insert that in the door, you line it up so everything lines up, you adjust the thickness, make it nice and firm. And then, when you put this on, you have something to screw your plate into.
Great. So the reproduction hardware is actually solving a lot of
It
problems.
sure is.
All right, but what do you say we stick with the antique hardware? And that's going to be a problem for us because, well, look, let's take this rosette right here. Get the bore insert out. That rosette's not going to work.
No, it's going to fall right through that 2 1/8 inch hole.
And I was thinking that this would be the backplate that we put on, and we've got a problem.
We sure do. We have to fill that hole. So I'm going to show you how to take out the old one and fix the hole. Okay, now the first thing we want to do is remove this old knob. We'll just take the screws out. Okay, and now we'll pull out the strike arm. Well, they definitely used a screw that was too big for that.
Well, they only used one of them.
Yeah, I know. I'm going to slide out the striker. I'm going to start to remove some of this filler. Look at this, comes right out.
Yep. And there's filler there because originally there was a full mortise lock like this, and it filled that big cavity. When they took that out and replaced it with this, they had to backfill it with some blocks
They
and
had
some
to fill
putty.
it up, that's right. They didn't do a very good job of it either, I must say.
So that means it's going to pop out pretty easily?
Right, let's hope so. It should come right out. Oh, yeah. Let's see how that fits. Look at that. Sits right in there. I have to trim it out a little more right in here to seat that in there nice. And now we have to deal with patching that hole. Rather than try to patch just the round hole, I'm going to patch this whole area right here.
And by patch, you mean you're actually going to cut it away and put in a new piece.
Right, and that's going to be called a Dutchman. So we're going to fix this damaged part of the door right here, and also this edge that's broken. To do that, I've cut a template out of a piece of medium density fiberboard. I'm going to line it up with the edge of the door, and I'm going to square it up. I'm going to clamp it right to the edge of the door, nice and tight. Okay, the size of my patch can be any length I want it to be as long as it's longer than the mortise that the lock fitted.
Why is that?
Well, because I need something to fasten the patch to.
Right.
The width of the patch can be whatever I want it to be as long as it's wider than the diameter of the hole. But in this particular case, I'm going to make the patch from this side of the hole all the way over past the edge of the door.
And so why come all the way to the edge?
Well, because I want to patch this edge at the same time.
Now, what about the thickness?
All right, what I did is I took a piece of standard pine and I ripped it down to a little bit thicker than I want the patch to be, so I'm going to set my router a little bit shallower than the thickness of the patch.
And you're going to use a plunge router.
Yeah, and in the plunge router, I have set up at the bottom a collar right here that will ride along my template in an upcutting spiral bit. Now I want to square up the corners. Okay, now I want to mark the length of my Dutchman and cut it on my saw. All right, let's see how it fits. It's pretty good.
Looks really good.
Okay, so now I'm going to glue it.
And here's where we can see why you overcut the length, because we've actually got some meat to glue into here.
That's right. If I had cut it too short, I have nothing to patch it to. So now I'm going to take my piece and I'm going to push it right into the wet glue. Let it ooze right out of there. All right, now you can see that our patch is sitting proud of the door on all three sides and also proud of the edge. So what I'm going to do is I'm going to knock that down using my hand plane, both on the top and the side. Now I'm just going to push a little bit of yellow glue in the crack, and I'm going to force the glue into the crack with my finger, along with a little bit of sawdust. Make up a little bit of my own filler. All right, Kevin, and that's how you do a Dutchman.
That's great, Tommy. Absolutely seamless.
All right, so all we'll do is we'll patch the other side, prime it, paint it, and then we're ready for some new old hardware.
And when that new old hardware goes on, this door is going to look great. Nice job.
Thanks.
Richard, we often hear the term heat pump, and we know that is something that we can use to heat and to cool the house.
That's right. So a few definitions. First of all, there are two types of heat pumps. One is an air source heat pump. We've seen them as really just an air conditioner that can actually either heat or cool the house. And you see the condenser outside. The other is a geothermal or ground source heat pump.
Right, and the idea behind the ground source heat pump is that in the winter, it will extract a little bit of heat from the ground and dump it into the house.
That's right.
And in the summer, it will dump the heat from the house and put it into the ground.
That's right.
My question to you is sort of how does it move that heat in and out of the ground?
Well, the key component for any of these geothermal heat pumps is to have some interaction with the ground, so it needs some sort of well. One type of well is a closed loop filled with antifreeze that circulates horizontally about 5 to 10 feet below the surface. Or you can install the same closed loop of antifreeze vertically into a well that may go down hundreds of feet. A third option is to have an open loop in which groundwater, not antifreeze, is pumped out of the ground through the heat pump and then returned to the ground. The key for any of these loops, though, is that we're always going to find 50-degree temperature both winter and summer under the ground.
Yeah, but I don't know many people who think that 50 degrees is a comfortable temperature to keep the house in the winter.
Right, but that's where the heat pump comes in. We're going to use the basic refrigeration cycle that we see in every window air conditioner, every refrigerator, even to cool our cars, to use that 50-degree water to make your house comfortable. The water or antifreeze is pumped into the heat pump, and in the winter, the heat is transferred to a closed loop of liquid refrigerant. That refrigerant now goes into a compressor, which uses electricity to compress the liquid refrigerant, turning it into a gas and making it very hot, maybe 130 to 150 degrees. In a typical forced air application, air is blown across the coils of that hot gas, heating the house. The refrigerant is then cooled by the air, and it turns back into a liquid, and the process repeats. The same equipment can be used to cool the house in the summer, simply by pumping the refrigerant in the opposite direction.
All right, so I get the theory of how they work, but what do the systems look like?
Well, recently I took a homeowner to see one of these geothermal systems in operation. So we got an email from you curious about geothermal heat pumps, and you're building a new house.
That's right. I just recently bought some property on a lake, and
Great.
I'm in the planning stage of the heating system.
Well, I thought I would bring you here. This homeowner, about 6 years ago, decided to put in a geothermal heat pump. That's a ground source heat pump. Now, most people might know a heat pump because it might have equipment like this on the outside. This is called a condenser. Now, when it's in air conditioning mode, heat is absorbed from inside the building into these refrigerant lines, and it dumps to outside. When it's a heat pump, it also can reverse, and it actually can be looking for heat from outside to be absorbed into the refrigerant to go into the building. The problem is it gets really cold here, and there's not much heat to be had. How cold does it get around here?
It's freezing most of the time
That's
in
right.
the winter.
So now, with geothermal, we actually could use the heat that is below our feet, down under the ground. Once you get down to 4 or 5 feet down, it's about 45 to 50 degrees down there. So now you got to figure out how you're going to collect that energy. So you could put a bunch of pipes down, 5 feet down, to collect the energy. You could do a closed loop, but this homeowner chose to put a well like this. This is actually about 400 feet down. At the very bottom of it, there's a pump. And it's going to take that water and pump it up and go into the house where we can use it to heat the building. Let me show you. David built this house about 6 years ago, but it wasn't originally a geothermal system, right?
No, it wasn't. The house was heated with these two propane gas-fired boilers.
Yeah.
They provided the hot water for domestic use.
For the faucets, sure.
For the faucets, exactly. And also provided the hot water for the air handler that provided the heat for the house.
This is called HydroAir. It's a pretty standard package nowadays. You got a unit here with a fan in it blowing air across this hot water heating coil that gets its temperature from the boiler. It's almost like an automobile radiator, and that's how the air gets heated. Down here, there's a cooling coil, and that connects to the condenser outside to make the air cold in the summer. But this is all abandoned now, right? We're only using this air handler, no longer the boiler or the condenser.
That's correct. What happened is that shortly after we moved in, the price of propane fuel tripled. We started out at 89 cents a gallon, and I think everybody knows where
That's right.
fossil fuels are now in terms of price.
So that got your attention.
It absolutely got my attention. So I had to come up with some other type of solution for heating the house.
So let me show you how a geothermal system works.
Please.
Remember that wellhead outside? The pipe actually comes into right here. So here's that 50-degree water that's going to come in, comes across the ceiling, and now it goes right over to here, and it comes down into this heat pump right here. Now inside this heat pump, there's a heat exchanger, and there's the basic refrigeration equipment that we see in every refrigerator or air conditioner. So what happens is that heat exchanger picks up that 50-degree temperature, and now it gets absorbed into the refrigerant. Now when that refrigerant gets compressed and get really hot, that 50 can be 120 or 130 degrees. So now that hotter refrigerant comes over here, and now when that air blows across it, it can actually heat the air enough to heat the building. Refrigerant gets cooler, goes back to that 50-degree water, picks up more temperature, and the cycle continues. In the summer, it's just the opposite. It picks up heat from inside the building. Now it takes it back and it dumps all that heat down under the ground and back into another well outside. So it's pretty interesting. It works simply and beautifully, no condenser outside. Now, you had to make a decision here. How about the operating costs for you?
It's reduced my operating costs for heating and cooling by about 60%.
Really?
Yes.
But you had to spend a little bit for it, right?
Oh, yes. There was a substantial investment for all of the interior equipment plus drilling the well on the outside of the house.
So what do you think the payback is?
It's going to take about 5 to 6 years to break even, but you know, it's a long-term investment, and I think it's been worth it.
Well,
so
you're coming up on the payback period right about now, aren't you?
That's right.
Congratulations.
Okay.
So what do you think?
5 or 6 years is not a bad time frame.
It isn't long, is it?
Seeing this system has really helped me to understand it, and it may be something I'm really interested in for my house.
Well, thanks for letting us poke around your
Okay,
basement.
you're
Thanks.
welcome.
Well, it looks like she is sold on the system, but of course, at a 6-year payback, I suspect most people would be.
Yeah.
What do these systems cost?
Well, there's a lot of variables. One, and the biggest one, is drilling. You know, that guy spent, I think, $25,000 for the wells.
Wow.
Now, he had to drill through rock. That gets expensive. A lot of times you can drill down and not get the water you want out of the wells. You have to drill another one. So it can add up. The other is the available fuel around you. What's it cost you?
Right, and in his case, he was using propane, and those costs tripled. So the more expensive the available fuel is, the shorter the payback
Sure.
period. But if you've got less expensive fuel, that's going to mean a longer payback period
Absolutely.
for this system.
That's right.
So his payback was 6 years. What's the range that you've seen in terms
I've
of
seen
payback?
it all over the map. I've seen it 6, I've seen it 15 and 20 years. It really depends on the complexity of the system and all these variables we're talking about. Now, the government is helping you, though.
Oh, okay.
There is a 30% tax credit with no cap, so that actually helps. And really, I think the geothermal is going to be an important part of our energy future going forward.
All right, well, great information on an interesting system. Thank you.
Thank you.
Well, if you've got questions about your house, we'd love to hear from you. So keep your letters and your emails coming. And until next time, I'm Kevin O'Connor.
I'm Richard Theory.
For Ask This Old House. Next time. Welcome back to Ask This Old House, where we'll go anywhere to answer your home improvement questions. Today we're going to be splitting some wood. Oh, yeah. Whoa.
Pretty good, huh?
Not so bad.
That's next time on Ask This Old House. If you have a question about your house or a tip you'd like to share, please let us know. Visit our website, pbs.org, for expert advice, step-by-step videos, and much more. This Old House magazine, the companion to the television series, provides advice from our experts that you've come to know. You can use your credit card to order 10 monthly issues for $10 by calling 1-800-221-5900.